Okay, today topic basically is chapter 1 review. Okay, that's what we do. We're going to do chapter 1 review. Let's see, what is it? 9, 7, 17. Okay, so write this solution of this number line in interval notation. So, we know if it's a solid dot, it's a bracket. Open dot, it's a parentheses. We're going to go parentheses, -3, comma, 4, bracket. That's it. That's it. Thumbs up? Pretty easy? Okay, good. Okay, number 2, graph the number line of the set. Okay, so I got to for sure put a -4 on my graph, because that's one of the important points. I should put a 1 on my graph and a 4. And again, if you want to put all of the numbers in between, go ahead. I'm not going to, because I know they're there. I mean, I know the numbers in between, but I just don't do it, okay? Does that mean I'm lazy? Maybe. I don't know. Anyway, we only need the important ones, right? Okay, so here's what I know. There's no little equal sign on the -4. So on the -4, I'm going to make sure I put a open circle. There's a little equal sign on the 1, so I'm going to make a closed circle, okay? There's a little equal sign on the 4, so I'm going to make it a closed circle, right? So far, so good. Now, let's read this. X is greater, if I read it backwards, x is greater than -4, but it's also less than or equal to 1. So I'm going to shade in between, okay? Shade in between there. And then when I see the or, it means I'm going to leap over, right, and do a second shading, right? I see the or. So do my second shading, I see x is greater than or equal to 4, so just go greater than or equal to is all the way to infinity, okay? How's that? All right. Number 3, to list them, what I like to do is, I'm going to get the decimal equivalent of all these things. So I already know what pi is. Pi is 3.14. Square root of 3, and if you're not sure, on the calculator, you can always just check it out. Square root of 3, it's about 1.73. Okay, so you can check it out. 1.73. 4/5, I know that's 0.8. -4, 0, 2. Okay, so I got it. So now list numbers in order from least to greatest. So here we go. The smallest on a number line, right? Smallest on a number line. Alexis, can you see that? Okay. Do you want to sit a little closer? Let's have you sit a little closer, okay? Yeah, you want to sit next to Emma? Can you see better if you can sit next to Emma? So, the very smallest is my -4, right? Okay. Then my -1.2. Is that better?
Yeah.
Good. And then what do I have next after the 1.2? Is it 4/5? No, 0. I almost forgot 0. 0, man. 4/5, right? What's next? 2, and then pi. Okay. Let's list them. Okay. So -4 is an integer. Most specifically. Oh, I did forget the square root of 3. That's got to go right there. Square root of 3, comma, infinity. Thank you. See how easy it is to make mistakes. All right, so listen. Don't put down all real numbers. You can argue. You can say, well, Mr. Davies, it is all real numbers. Yes, but I want the very specific. Savannah, did I miss something else? Yep. Thanks, Savannah. See, I do make mistakes all the time, don't I? I'm even admitting it to it on film, huh? Sorry. Yeah, you're right, Savannah. Okay, so -4 is an integer. Specifically. -1.2 can be a fraction, so it's a rational number, okay? 0 is very specifically a whole number, okay? 4/5 is a fraction, so it's a rational number. Square root of 3, now that I remembered it and put it in the right spot, it is an irrational, right? 2 is going to be a natural number. Specifically, it's a natural number. And pi, of course, is irrational. So tomorrow I'm looking for the most specific name. Okay, what is it specifically? Because as an example, real quick, 0 is a real number. 0 is a rational number. 0 is a whole number. 0 is also a integer. But specifically, it is a whole number, okay? All right, number 4, here we go. Am I okay? Am I going too fast? All right, so let's do number 4. I am going to leave the 4 on the outside because it's a regular 4. But with the 18, I'm looking for what times what makes 18. So give me two numbers. What times what? Okay. Give me two better numbers. I need a perfect square. Give me a perfect square. What times what makes 18? I need to write those back down, don't I? 9 and 2. Do you want me to write those back up again later? Okay, 9 and 2. Square root of 9, square root of 2. We like those because there is a square root of 9, right? If I take the square root of 9, I get 3, so I get 4 times 3 times the square root of 2. And 4 times 3 is 12 square roots of 2. Thumbs up? Okay, good. Number 5, can't add them, but maybe they will be the same. Maybe they will, okay? So I'm going to go 3, and again 18, I just did 18, so let's just do 18 just like we did, 9 and 2, right? Okay. And what about 50? What about 50? What do you think, Connor? 25 and 2. How about 25 and 2? Okay, very good, okay? Square root of 9 is 3, so I got a 3 times another 3 times square root of 2. Square root of 25 is 5, so I got the 2 times the 5 times the square root of 2, right? I get 9 square root of 2 plus 10 square root of 2, right? Because I just multiply 3 times 3 and I multiply 2 times 5. Add them together and I get 19 square root of 2. How's that? Thumbs up? Okay. Number 6. Let's just multiply them. 5 times 10 makes the square root of 50. Okay, hey, we just did 50, didn't we? We just did 50, so we know how to break it up, right? We just did 50. So I know 50 is 25 times 2, square root of 25, square root of 2, right? And the square root of 25 is 5 square roots of 2. How's that? Thumbs up? Okay. We can do this tomorrow, right? Yeah. Okay, 7. It's a fraction, so the first thing I'm going to do is break it up into 2 square roots. And again, if I get going too fast, will you slow me down? Okay, promise? Okay. I know what the square root of 16 is, so I'm going to go straight to calling that 4 over the square root of 5. Because the square root of 16, boom, plain old 4, right? Okay, now, we have a problem. You can't have a square root in the bottom, that's the rule. So we fix the problem with the problem. Square root of 5, square root of 5, right? Let's see what I get now. I'm going to get 4 square roots of 5 over the square root of 25, right? But I know what the square root of 25 is, and that's 5. So I get 4 square roots of 5 over 5. Don't cancel those 5s. Don't cancel the 5s. Because that is not 5. That is not 5. It's 2.24 blah blah blah, okay? That is not 5. It is not a 5. It's a square root of 5, okay? Alright, turn the page. Alright, negative exponents. We can do this, right? So, first of all, let's just do this. Let's just rewrite the z to the third on the bottom. Okay, right off the bat. Just bring that down. Okay, that's all I did. Just brought the z to the negative 3 and brought z to the positive 3 down, okay? And now, an exponent to an exponent, you multiply, right? You multiply because you've got z5, 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 so there's 4 z5s, or as I say z, I meant x. X 20 over Z12. Thumbs up? Good. Nice. Okay, number 10. Oh, I'm sorry, number 9. See, I get ahead of myself. Okay, again, fraction bar, right? I'm going to move x to the 5th. X to the negative 5, move it up, right? Make it x to the positive 5. X to the negative 2, move it down, make it x to the positive 2, okay? Y to the negative 1, I'll bring it up and make it y1. Now I'll keep y to the 4 there, okay? How am I doing? Now, I still got the 30 and the 5, okay? Now it's a fraction, right? How am I doing, okay? It's a fraction, so let's just deal with fraction. Okay, so first of all, 30 divided by 5. Those are just regular whole numbers. 30 divided by 5 is just 6. Everybody agree with that? Just plain old 6. So I'll put my fraction bar and I'll put a 6 right there, okay? 2 of these x's here will cancel 2 of these x's, so I subtract. I'm going to subtract the exponents. I get x to the 3rd on top. y1 plus y4 makes a total of y to the 5th. Nothing really on the bottom. You could put a 1 on the bottom. You could, but that's kind of redundant, so we'll just leave that answer right there, okay? How am I doing? Thumbs up? Good. Okay. 10. Same thing. Let's make a fraction bar, okay? Negative exponents. Okay, y to the negative 5, I'll bring it down and make it y5, right? X to the negative 3, I'll bring it down and make it x3. Y to the negative 2, I'll bring it down and make it y2. Okay? Now, all I did is I moved just the negative exponents down and I made them positive. Now, what's left is the 4x to the 5th times my 12, because everything else is moved, right? So now, we're still multiplying, so let's see what I get for an answer. I'm going to have my 4 times 12, because I'm multiplying, it gives me a 48. Oh, let's see what to do about the x's. Well, the x's, I've got 5 of them here, 3 of them here, so 3 of these will cancel with 3 of these. I'll be left with x2 on the top, okay? 3 of these will cancel 3 of these. The y's, I'm going to combine them because they're together, and I'll have a y to the 7th on the bottom. Okay, now properties. All right, let's see. If we go back to our notes, let's see what we got for properties. Okay, so if I go back to my notes, I've got these darn properties. So, here's my properties, and you may want to put these on your note card, but I've got all the properties: additive identity, multiplicative identity, additive inverse, multiplicative inverse, commutative property, associative, distributive property. Okay. So these are my properties, so let's see if we can identify it. So number 11, x plus y equals y plus x. Which one do you think that one is? You guys remember which one that one is? It is commutative, because see, instead of x's and y's, I got a and b's, right? So it's definitely commutative prop of addition. But I'll go add, I'll abbreviate, okay? How's that? Commutative property of addition, okay? How about 12? Got 12 times 1/12 equals 1. Let's see if we can find something like that on there. Which one do you think it is? Yeah, multiplicative inverse, right? So it's multiplicative inverse. Got it. Good. Let's see. 7 plus 0 equals 7. All right, let's look at my notes. 7 plus 0 equals 7. 7 plus 0 equals 7. Which one do you think it is? Yeah, additive identity. You guys see it right there? 7 plus 0, but it's n. So it's additive identity. Additive identity. Um, 14. 8 plus 4 plus 6 equals 8 plus 4 plus 6. Let's look at my notes. Do you see it? Yeah, you see the parentheses, how the parentheses got shifted? See how the parentheses got shifted? Same thing here. So it's the associative property of addition. Prop of addition. Okay, and as long as you have these, you guys are good. Okay, x plus a negative x equals 0. Okay, well, which one's that got to be? X plus a negative x equals 0? X plus a negative x equals 0? Yeah, there you go, additive inverse. You guys see it's right there? Additive inverse. Okay, we're getting there. And finally, 3 times x plus y is 3x plus 3y. You guys already know that, I'm sure you do. What's it called? Yeah, it's just distributive property. Okay. Alright, so here's what we're going to do. We're also going to do a little homework to practice some more, because there's going to be some problems off of the homework that may appear on the quiz tomorrow, okay, or ones just like it, right? So we do want to do page 43, 3, 4, 10 to 13, 18 to 21, and